Good evening, my dear students. Myself, Dr. Apiluddin Ahmed. So today I will start a new chapter, and the chapter is our matrices and their properties. Okay. Basically, this chapter is a small portion of linear algebra. Yes. So it's a matrix. So matrix is nothing just a rectangular arrangement or rectangular array of some numbers or some object or some functions. Okay. So suppose we consider some objects, suppose some numbers here. Yes, suppose 1, 2, 3, 5, 7, 9. Yes. So this is an arrangement. Yes, this is an arrangement, and this type of arrangement is called rectangular arrangement, or here we call this is a matrix. Okay. So you see here, this object we arrange in horizontally, and these are vertically we arrange here. Yes. So these are called the rows. Yes, these are क्या है? These are rows of this matrix. Yes, these are rows. These are called these of this matrix, and here you see 1, 5, 2, 6, and 3, 9. These are called here columns. So these are the columns of this matrix. Okay. So guys, matrix is nothing just some arrangement or a rectangular arrangement of object. And here also you see here 1, 2, 3, 9, 7, 5. These are called elements. Okay, these are called elements of this matrix. Yes. So see here in our rectangular arrangement, these horizontal lines, these are called the rows. Yes, and these particles, yes, these vertical lines or these numbers are called columns. Yes. So here 2 rows and 3 columns of this matrix. Okay. And the general form of a matrix or standard form of a matrix is matrix, or this is an arrangement which is called here standard form or general matrix, like this way, na? IJ way. And this I will denote the rows. This I will denote rows, in which row this element is belong, and the J will denote columns, how many in which columns this elements is belong. Yes. So here you see 1 on, that means this element is belong to first row and first column. Here you see second row but first column. Yes. And if this on, in which row this elements is belong here, nth row and first column. Yes. This one A2, 3, that means this element is in second row but third column. Yes. So for any elements, if we consider here, suppose A7, 5, that means this will represent here this element is in 7th row and 5th column will be. So guys, this is our matrix. And how many rows are there, guys? You see 1, 2 increase हो के कितना तक आया है, n तक. So how many rows? 1, 2, 3, 4 करके n तक आया है. That means n rows are there, and we denote this way, n. And here you see how many columns are there. The second number is represent the columns. So 1, 2, 3 up to कितना तक गया है, m तक गया है. That means how many columns are there? M columns are there. That means this here will be m. Yeah. Just this is a notation. हम लोग कोई भी एक मैट्रिक्स का n rows and m columns होने से we denote this way. ठीक है, एक suffix करके लिख देता है बस. So this is a matrix, and this is the standard or general form of a matrix, and which m number of rows is n and number of columns is m. Is it okay? I think now you can remember. And this matrix we can write like this way also. Okay, this way you can write. This is A of ij, and where I is varies from 1 to up to n, and j is varies from 1 to up to m. And you write like this way, n by m. Yes. So this is the matrix of A, whose number of rows is n and number of columns in m. Yes. So this is the matrix. For example, if we consider a matrix with 2 rows and 3 columns, this will be. This is a matrix. Yes, this is a matrix whose how many rows are there? There are 2 rows, no? This one and this one. There are 2 rows are there. How many columns are there? 1, 2, 3. These are the columns, so here will be 3. So this is the matrix. Suppose this is A dash. So this is our matrix. Yes guys, so here what you see here, so a matrix is nothing, just a rectangular arrangement of some numbers, some objects here, and the objects are called the elements of that matrix. And if a matrix has n numbers of row and m number of columns, then the matrix will be this one. Yes, for example, here we consider a matrix with 2 rows and 3 columns, then we write like this one. Yes, and here how many elements are there? 1, 2, 3, 4, 5, 6. So 6 number of elements are there. Okay, of a matrix. Yes, order of a matrix. So guys, if a matrix has n rows, how many rows? N rows, n m columns. If a matrix A has n rows and m columns, then order will be here n by m. This will be the order. Yes, you see, this is not the general multiplication. This is you read here like this way, n by m. We read like this way. This is not n multiple m. Yes, we read like this way, n by m. So if a matrix with rows n and number of columns is m, then the order of this matrix will be m by n. So guys, you see, for this matrix, what will be the order? What will be the order of this matrix? The order of this matrix will be here 2 by 3. Yes, so this is the order of this matrix. Again, you see another notes are there. Number of elements. Number of elements. So you see here for this matrix, this one, for this example, how many elements are there? 1, 2, 3, 4, 5, 6. There are 6 elements are there, and these 6 number we can easily find by multiple these 2 numbers. You will get the number of elements. Yes, you see 2 into 3, you will get 6. Yes, so how many elements will be there for any matrix whose number of rows is n and number of columns is n? Will be nm. Yes, nm will be the number of total elements of that matrix, capital A. Yes, that means this matrix, this general matrix, how many elements are there? The number of elements will be here nm. This is the number of elements. Yes, this will be the number of elements. And what will be the order of this matrix? Order of the matrix will be n by m. Yes. So just you remember these 2 things. These 2 are the important types of matrices are there. One is called raw matrices. One is called raw matrices. So raw matrices is nothing, a matrix in which has only one row. A matrix which has only one row is called raw matrix. For example, this matrix, suppose 1, 2, 3, 5, 7. So this is a matrix. How many rows are there? 1 rows are there. How many columns are there? 1, 2, 3, 4, 5. 5 columns are there. So how many rows are there? 1 row. So that's why we call here this matrix is a raw matrix. Similarly, another matrix is there, that is called column matrix. So a matrix which has only 1 column, suppose A, B, C, D. Yes, so how many columns are there? Here 1 columns are there. How many rows are there? 1, 2, 3, 4. So 4 by 1. So how many columns? 1 columns. That's why this will be the column matrix. Yes. Now you see another matrix or important matrix is there, which is called square matrix. This is important. A matrix is said to be square. A matrix is said to be square if the number of rows and number of columns are equal. That means number of rows and number of columns equal होना चाहिए. Yes, if number of rows equal to number of columns. If this is happen, then we call the matrix is square matrix. For example, if we consider this matrix, yes, suppose 0, 5, 7, 9 1 2 minus 1 5 2. So you see how many rows are there? There are 3 rows are there, 1 2 3. So 3 rows are there. How many columns are there? You see 1 2 3. There are 3 columns also are there. So 3 by 3. So number of rows and number of columns are equal here. So this is a matrix, and which is called square matrix. Hope you can easily remember this matrix. Okay, another matrix is there which is called diagonal matrix. Diagonal matrix is nothing a square matrix. First of all, the matrix should be square. Suppose we consider x, y, z, p, q, r, a, b, c. Yes, suppose we consider a 3 by 3 matrix, then this matrix is called diagonal. So before I am going to the definition of diagonal matrix, you see these elements are called principal diagonal element. Yes, principal diagonal elements. Yes, so and you remember this is called the principal diagonal. Yes, that means these are the principal diagonal elements, and these all are nothing. These are not the principal diagonal elements. Yes, so now you see, if a matrix or if a square matrix has all the non-diagonal element or non-principal diagonal elements, that means these are, if these are 0, yes, if a matrix whose has all the non-diagonal elements are 0, then the matrix is called diagonal matrix. Yes guys, for example, if we consider this matrix, yes, suppose A 0 0 0 B 0 0 0 C. You see, for this matrix all the non-diagonal elements are 0 here. Yes, this is the diagonals. So here all the non-diagonal elements are 0. That means this is an example of diagonal matrix. So this means this is called diagonal matrix. Yes. So guys, a diagonal matrix is nothing, just a square matrix in which all the non-diagonal elements are 0. Okay, so this is an example of a diagonal matrix. Yes, and you see for this types of matrix here, scalar matrix. So what is scalar matrix guys? Matrix capital A is said to be a scalar matrix if all the elements or all the diagonal elements are equal. Yes, that means if we consider, suppose we consider this matrix, suppose A 0 0 0 A 0 0 0 A. So you see, first of all, this is a diagonal matrix because you see all the non-diagonal elements are 0 here. All the non-diagonal are क्या है 0 है. That means this is a diagonal matrix, and you see all the diagonal elements are equal here. A. All the diagonal elements are equal. So this type of matrix is called scalar matrix. Yes, this type of matrix is called scalar matrix. Yes, that means a scalar matrix is always a diagonal matrix in which all the diagonal elements are equal. Another type of matrix are there which is called identity matrix. So identity matrix is nothing, a matrix in which all the diagonal elements are equal to 1. That means a matrix of like this one. You see, this will be a scalar matrix. Yes, 0 0 1. This is a scalar matrix but in which all the diagonal elements are equal to 1. So this type of matrix is called identity matrix. Identity matrix. And the identity matrix we denote in generally we denote by I. We denote by this symbol I. So in case of diagonal matrix or scalar matrix or identity matrix, whatever we have discussed about these three types or this type of matrix, the matrix should be first square, and then you see if a square matrix and whose all the non-diagonal elements are 0. all the non-diagonal elements are 0, then the matrix is called diagonal matrix. And then you see, if a matrix or if a diagonal matrix in which all the diagonal elements are equal, then the matrix is called scalar matrix. And if a diagonal matrix or scalar matrix in which all the diagonal elements are equal to 1, then the matrix is called identity matrix. So these are the identity matrix. And here also you see what is the order of this matrix. This is the order of this matrix is 3 by 3, and here 3 by 3 matrix. And you see, in case of square matrix, here since these are square, and you see, and another thing you remember here, this is a square matrix whose order is 3 by 3. So you see, sometimes the in case of square matrix we read like this way, this is a matrix of order 3. Yes, okay. So these are the some examples or few examples of diagonal matrix, scalar matrix, as well as the identity matrix. Okay. So another type of matrix is there, this is called, which is called null matrix or zero matrix also we consider. So zero matrix is nothing, a matrix in which all the elements are 0. A matrix in which all the elements are 0, then the matrix is called null matrix. Okay, so this is an example of null matrix and whose order is a 2 by 3. Yes. So now come to another type of matrix, and which is an important matrix, which is called triangular matrix. So guys, here there are two types of triangular matrix. One is called upper triangular matrix. Yes, one is called upper triangular matrix, upper triangular matrix, and another is called lower triangular matrix, lower triangular matrix. Okay. So what is an upper triangular matrix? So a matrix of this form. Yes, suppose this is a matrix and this is the principal diagonal element. Yes, this is the principal diagonal element. So if a matrix in which all the elements which are below the diagonal elements or below the principal diagonal elements are 0, a matrix in which all the elements which are below the principal diagonal are 0, then we call the matrix is nothing, upper triangular matrix. For example, you can choose this matrix. Yes, suppose 1 2 5 0 3 2 0 0 1. You see, so this is our diagonal, principal diagonal, and below principal diagonal all the elements are 0. So this is a matrix, and which is called here upper triangular matrix. Yes, so that means the upper triangular matrix is nothing, is a matrix in which all the elements which are below the principal diagonals are 0. Okay, similarly lower triangular matrix is like this way. Yes, a matrix, and this is the principal diagonal. So if all the elements which are just above the principal diagonals are 0, yes, if all are 0 which are above the principal diagonal, this type of matrix is called lower triangular matrix. For example, if we consider this matrix, yes, 1 0 0 0 3 5 0 0 7 2 3 0 0 0 1 2. You see, this is the principal diagonal, and all the elements which are the just upper the principal diagonal element just above the principal diagonal, yes, are 0 here. That means this is a matrix which is called lower triangular matrix. So guys, these two type of matrices are most important. So hope you can easily remember these two type of matrices. One is called upper triangular, another is called lower triangular. Here again I will repeat here. In case of upper triangular matrix, all the elements which are below the principal diagonals are 0. Yes, that means वो प्रिंसिपल डायगोनल्स का ऊपर में जो रहेगा उसमें नॉन जीरो कुछ एलिमेंट्स रहेगा. बट इन केस ऑफ लोअर ट्रायंगुलर मैट्रिक्स, देन above the principal diagonals all the elements are 0, and principal diagonal का नीचे कुछ non zero elements will be there. Yes, so this type of matrices are most important. So now you see transpose of a matrix. Yes, this is also an important operations on matrix. So a matrix, suppose A is there, and if we interchange all the rows and columns of this matrix, then you can obtain a matrix, and that matrix is called here the transpose of a matrix. Okay, and transpose of a matrix of A is denoted by AT or A dash. That means if we obtain a matrix by interchanging the row of columns, you will get a matrix. Then resultant matrix is called the transpose of the previous or original matrix. So for example, if we consider a matrix like this way, yes, A, B, C, X, Y, Z, then here the transpose of this matrix we write like this way, A to the power T, and this will be this one. Just you interchange this row as a column, so that means A, B, C. Yes, you interchange this row and column. So here also X, Y, Z, if we interchange this thing, these rows and columns, so you will get a matrix. Yes, and this is called the transpose of this matrix. Yes guys, hope this is clear. Now you see conjugate of a matrix. So conjugate of a matrix, and in case of a matrix whose elements are some complex number, then basically we are discuss about the conjugate matrix. Okay, so suppose we consider a matrix like this way. Suppose a matrix this one, 1 plus I, 1 minus of I, yes, I and 3. So this is the matrix. Now if we take conjugate of all these matrix, all these elements, yes, इसका अंदर में जितना elements है all are complex number है, just you take conjugate of this all these elements. So इसका conjugate लेने से कितना होगा guys, 1 minus I हो जाएगा. इसका conjugate कितना होगा, 1 plus I होगा. इसका conjugate कितना होगा, I minus I होगा. इसका conjugate, this is a real number, and real होने से तो उसका conjugate same ही होता है. So this is a matrix which is called conjugate of this matrix, and we denote that conjugate of this matrix is like this way, 8 bar. Okay, that means a matrix obtained by taking conjugate of all the elements. Yes, you will get a matrix, and that matrix is called the conjugate of the original matrix. Okay, so this is the conjugate of a matrix. And another properties is there which is called the transpose conjugate of a matrix. Yes, transpose of a conjugate of a matrix. That means if we first you find the conjugate of a matrix, and if we transpose this one, yes, if we transpose this one, if we transpose this one, transpose means just you interchange the rows and column of this matrix. That means if we interchange this one, that means 1 minus I, and then 1 plus I, okay, minus of I, and then 3. Yes, here we transpose this matrix, and this is called the transpose conjugate of this given matrix A, and we denote this one by like this way, A to the power T, theta. Okay, that means transpose of a conjugate, transpose conjugate of a matrix we denote like this way, and this is the transpose of the conjugate. Yes, so for transpose conjugate of a matrix, first of all we need to find the conjugate of a matrix, and then just you take the transpose of that matrix, you will get the transpose conjugate of a matrix. Yes, so I will take an example another. So suppose B is a matrix whose elements are these one, 5 of I, okay, 2 plus I, and 3 minus of I. Suppose this is our B, and suppose we need the value of this one, transpose conjugate of this B. Then you find the B bar or conjugate of B. Then what will be conjugate of this B? Just you take the conjugate of all the elements. So the conjugate of this one will be 3 minus of I, here will be 3 minus of 5I, here will be 2 minus of I, here will be 3 plus I. So this is the conjugate of this B matrix. Now you take the transpose. Yes, just you take transpose, that means just you interchange the rows and columns of this matrix. So this will be 3 minus I, here will be 3 minus of 5 of I, here will be 2 minus of I, here will be 3 plus of I. Yes, so this is the transpose conjugate of this matrix B. So hope now you can find the transpose conjugate of any matrix. Now trace of a matrix, guys. So what is trace of a matrix? So trace of a matrix is nothing, just sum of all elements which are in principal diagonal. Yes, principal diagonals. That means this is called the trace. So suppose we consider a matrix, and the matrix should be square. Yes, so this is our principal diagonal. Suppose here 1, 5, 7 as there, 3, 9, 2, 0, 1, 5. Suppose this is our matrix. Yes, suppose this is the matrix A. Then the sum of all these diagonal elements, yes, all the elements which are in diagonals is called here trace. Yes, so what will be the trace of this matrix? Yes, so trace of A will be here 1 plus 9 plus 5, that means this will be 15. So this 15 will be the trace of this matrix. Yes, and in short form we write trace is like this one, TRAC of A, trace of A. Yes, trace of A in short form. So trace of A